In this video, we're continuing our discussion on pushback creation and showing you how to work with this tool in both automatic and semi-automatic modes. As you probably know, the number of pushbacks, their configuration, and other parameters directly impact the quality of your mine plan. Pushbacks form the basis for long and medium-term scheduling, which in turn drives short-term planning. That's why, to achieve the optimal extraction sequence, you need powerful and flexible tools. And K-Mine provides exactly that. The pushbacks you generate in the Optimal Pit Boundaries module will later be used in scheduling to define production stages. So, what's required to build pushbacks automatically? First, you define the price adjustment factor for your final product, or rather, the corresponding pit shell, the desired number of pushbacks, the width of the working platform, the minimum top surface area of each pushback, the minimum pit bottom area, along with a few additional settings. Next, you'll find a group of constraints for the algorithm. These can include geometry-based limits like wireframes or polylines, as well as specific mining horizons. For now, let's leave those unchanged. Then we set the tonnage targets, how much material we want to extract within each pushback. This isn't a fixed number, it's a goal. If the algorithm can't meet it exactly, it'll apply what's called relaxation, loosening the constraints slightly to find the most realistic and workable solution. The calculation process takes some time, especially with large block models and complex interblock connections. This is expected. The algorithm goes through multiple steps, creating areas, checking constraints, validating geometry, and more. But the advantage is that each resulting pushback is guaranteed to be mineable, with a continuous working platform ensured. Another great feature in K-Mine is the ability to duplicate your setup, tweak the parameters, and generate new versions for comparison. That's exactly what we've done here. Created a second scenario with slightly different targets. And of course, the result is different, which gives us options. Sometimes automatic pushback creation will produce isolated zones that can't be mined efficiently. These will be listed in a separate section of the results, and it's up to you whether to include or ignore them. Now, let's talk about semi-automatic mode. If you add a spatial constraint, for example, define the first pushback manually. The rest can be generated automatically. This gives you more control over the first stages while still saving time on the rest. In our case, we used an open wireframe surface to lock in the first pushback and let the algorithm calculate the rest. There are also additional filters you can use to precisely control which blocks should or should not be assigned to a pushback. Getting these settings right, combined with a solid understanding of your deposit, often determines 75% of your success. When reviewing the results, you can choose between incremental and differential modes. Incremental mode shows only the blocks for the selected pushback. Cumulative mode includes all blocks from earlier stages as well. These display options also apply to the summary table, helping you analyze the results in detail. Once completed, the results can be written directly to the block model, so you can visualize them later without running the optimization module again. Finally, you'll see the calculated results represented as wireframes, just like your final pit shells. And as you know, these wireframes form the foundation for all downstream design work. Pushback generation is both an art and a science. It takes some intuition, a good understanding of your project, and the willingness to experiment. So go ahead, test it out, explore different scenarios, and enjoy the results.